Hi, welcome to today's math lesson. Our TEK is 8.10d. Our lesson target is that we will model the effect of dilated two-dimensional shapes on linear and area measurements, so perimeter and area measurements. We have a 4-question DOL at the end. So some vocab words to go over are the words center of dilation. Usually the center of dilation is going to be the origin, which is at 0, 0 point. Dilation is either an enlargement or a reduction. So either the shape gets bigger or smaller, depending on the scale factor. If the scale factor is less than 1, our shape gets reduced or shrunken. And if our scale factor is greater than 1, then our image or our shape gets enlarged or bigger. So the important rules are highlighted right here on this side. When a polygon is dilated by a scale factor k, then the perimeter of the polygon is also multiplied by k. This is true of any linear measurement of the polygon, such as a diagonal. So this rule is true even for the diagonals of the polygons or the shapes. So let's start off with finding the perimeter of this pre-image or original image. We have 2 is the length of one side and 1 is the length of the other. So I'm going to do 2 plus 2, which is 4, plus 1 plus 1, which makes 6. So my perimeter for my pre-image is 6. If I were to find my perimeter of my dilated image, as you can see, the rule is 2x and 2y, so our scale factor is 2. For the side length that was originally 1, it's now 2 because 1 times 2 is 2. For the side length that was originally 2, it's now 4 since 2 times 2 is 4. And if we add together 4 plus 4 plus 2 plus 2, we get 12. What this rule is saying is that whatever the pre-image perimeter is, which was 6, all we have to do is multiply it by the scale factor, which in this case is our coefficient of 2, to get our perimeter, which is 12. And then when a polygon is dilated by a scale factor of k, then the area of the polygon is multiplied by k squared, which is whatever the scale factor is squared or times itself. So this is true of any area measurement expressed in square units of a polygon or other 3D figures, such as the lateral area or the total surface area. So this also works for lateral area and total surface area. So for the same pre-image shape, our area is going to be 1 times 2, since we just multiply one side length by another, and that is 2. So our area is 2 units squared. And then to find the area of our dilated image, we have 2 times 4, which is 8. So this rule or this trick is telling us that all we had to do was take our pre-image area, which was 2, multiply it by whatever our scale factor was, squared. 2 squared is the same thing as 2 times 2. So we basically are doing 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that's also how we got our area. For this I do, it reads, a rectangle has a width of 3 centimeters and a length of 4 centimeters. Another rectangle is dilated from this rectangle with the scale factor of 2. So as you can see, the scale factor of 2 enlarges the image or makes the image bigger. We have to figure out what is the perimeter of the dilated rectangle and then what is the area of the dilated rectangle. So starting off, we have to find the perimeter of the pre-image and then the area of the pre-image. So our pre-image is outlined with this blue outline. So what I'm doing is 3 times 2 plus 2 times 4, or that's the same thing as 3 plus 3 plus 4 plus 4. So 3 plus 3 is 6, 4 plus 4 is 8, 6 plus 8 is 14. And then our unit of measurement is centimeters. I actually had originally written it in the wrong place. I wrote it in the dilated images perimeter, so I moved it up. And to find the dilated image's perimeter, I'm going to take the original perimeter, which is 14, and multiply it by the scale factor, which in this case is 2. So 14 times 2 is going to be 28. So my perimeter of my dilated image is 28 centimeters. Then for the area of the pre-image, 3 times 4 is 12. So we have 12 centimeters. And then to find the area of the dilated image, what I have to do is 12 times the scale factor squared. So 12 times 2 squared is the same thing as 12 times 2 times 2, which is 48. So our dilated rectangle's area is 48 centimeters squared. And just to prove this, if our scale factor is 2, that means we're doubling both the length and the width. So that means 3 times 2 is 6, so the side would be 6. And then 4 times 2 is 8, so the side would be 8. 4 times 8 to find the area of the dilated image is 48. And then if we add together 8 plus 8 plus 6 plus 6, we get 28. So that is the dilated image's perimeter. For this next I do, it reads, a souvenir shop sells standard size decks of cards and mini decks of cards. So this is the standard size, this is the mini size. A card in the standard deck is a rectangle that has a length of 3.5 inches and a width of 2.5 inches. The perimeter of a card in the mini deck is 6 inches. What is the area of the card in the mini deck? So basically we have to work backwards, right? So we're gonna start by doing the same thing. We're gonna find the perimeter of the standard card. So 2.5 plus 2.5 plus 3.5 plus 3.5. And that is 12 inches. So now we have to find the scale factor, right? So we know that the perimeter of the dilated image is 12. And then we also know from the problem that sorry about that. So we actually know that the dilated image's perimeter, which is what goes on top, is 6. And then our pre-image perimeter is 12. So we always have to start with the dilated image's perimeter on top. So we have 6 over 12. We're going to reduce that. So the factors of 6 are 1 times 6. The factors of 12 are 2 times 6. The common factor is 6. So that means that 6 over 12 can be reduced to 1 over 2. So our scale factor is half. So now we have to find the area of the standard card deck. So 2.5 times 3.5, and that is 8.75 inches squared. And so now that we have the scale factor and we have the area, what we're going to do is do 8.75 times our scale factor squared. So half squared is the same thing as 8.75 times half times half. When we multiply a number by half, that's the same thing as dividing it by 2. So we're basically doing 8.75 divided by 2, and that gives us 2.1875 inches squared. There's several we do problems and then some you do problems, and finally your DOL. Thank you so much for following along in today's math lesson, and see you in the next math video. Bye.